Friends, this is Shoaib Gujjar, and today I'm gonna tell you about the Euler's theorem, as this is our presentation topic. So I realize that some students have tough time in understanding the Euler's theorem, so that's why I decided to make a video for them. So Euler's theorem, basically Euler's theorem is all about the motion of a rigid body. Motion of the rigid body, and it is, in other words, you may say that the rotation of the rigid body. Rotation of the rigid body and the orientation of the rigid body. So it is all about the motion of the rigid body and rotation of the rigid body, orientation of the rigid body. These three terms are pretty same: motion, rotation and orientation. So the common word is in this terminology is rigid body. So to understand the Euler's theorem, you must know how about the rigid body. So first of what is rigid bodies? What is rigid body? So to understand the rigid body, let's suppose we have a kind of system of particles, any kind of system of particles. Let's suppose this is a body, any body, you may say that, and it consists of particles inside the body. So let's suppose these are some particle, and in between these interparticles there is a specific distance. Let's suppose the distance between these two particles is d1, and you may say in these two particles is d2. So in every particle which is inside the body, it has a specific distance among between with another particle. So if we rotate this body counterclockwise, or maybe in clockwise, or in any direction, if we rotate this body in any direction, and the intermolecular or the interparticle distance will remain constant, then that body is said to be a rigid body. If this body is, let's suppose we just rotate it counterclockwise, and the distance between these particles will remain constant, then there is no change in these particles, the distance between these particles, or in short, it does not deform. If it does not deform, then that body is said to be a rigid body. And you may say that rigid body is something rigid body is something which does not change, which doesn't change its structure when an external force applied on it. So a body is said to be a rigid body when it doesn't change its structure when an external force applied on it. Let's suppose if we hit this bodies with hammer, but still the interparticle distance will remain constant, then that body is called a rigid body. So Euler's theorem is all about the motion of the rigid body. This theorem is all about the motion of that rigid body. So now let's come to the business and Euler's theorem. Euler's theorem states that let's suppose to understand the Euler's theorem. Let's suppose we have a sphere, three-dimensional sphere. Actually, Euler's theorem is all about the three-dimensional motion. So that's why let's suppose this is a sphere, and let me give it a three-dimensional look so that it could be easily understand. Let's suppose this is a sphere. This is a sphere and this is the center point of the sphere. And if we put this sphere in a coordinate system, say suppose this is x-axis and this is the y-axis, and that is of course z-axis. So we just put this is in a coordinate system. Now what Euler's theorem states that any sphere when rotated will always have a fixed point that is not affected by the rotation. Let me write the definition. It is very simplest definition of the Euler's theorem. Any sphere when rotated will always have a fixed point that is not affected by the rotation. Any sphere when rotated will always have a fixed point that is not affected by the rotation. Now what does it mean? It means that this sphere is in three-dimensional. If we rotate this sphere in any direction, in clockwise, in anti-clockwise, or in any direction, it will always rotate around a fixed point. Let's suppose this is the fixed point around which this sphere will rotate in any direction, in any acrobatic, like we are moving, we are rotating it clockwise or counterclockwise, or in this direction or in that direction, in any direction, it will always rotate around this point, and this is called the Euler's point. Euler's point, and this point is denoted by the E for Euler, and a hat on the E, which denotes that it is a unit vector. So basically this was the concept of the Euler's theorem, that any sphere when rotated will always have a fixed point which is independent of the rotation. Doesn't matter what rotation the sphere will take, the fixed point will remain same, and the whole sphere will rotate around that specific point. Now to understand this, let's suppose we have a three-dimensional square. Let's suppose this is a three-dimensional square. We have a three-dimensional square. Sorry, I have a little bit difficulty in sketching the three-dimensional forces, three-dimensional pictures. So yes, it is getting let's suppose we have a three-dimensional square here, and it is a block. Let's suppose this is the center point, midpoint of the block, and there goes z-axis, and that is of course the y-axis, and here is the x-axis, and this is the origin, this is the center point. Now Euler states that if we rotate it in any direction, it will always always rotate around this fixed point independent of the rotation. So let's suppose we are just fixing x-axis, and the y and z-axis are we can make them rotate. So if we rotate this on x-axis on 90 degrees, let's suppose we just rotated this on x-axis and on 90 degrees, then it will just look like 90 degrees. Okay, it will just appear like shit, then it is wrong. So let's suppose if we rotate this is on 90 degrees by fixing the x-axis, then this will appear like it will just appear like this. So in this block we just rotated this block about fixed axis on x-axis 90 degrees, then this will just look like this. So this is a center point, and there you go for z-axis, it is z-axis, and this is the y-axis, and here is the x-axis. So these are basically these axes are these coordinates are fixed coordinates. So I am just trying to visualize that how a rotation does not affect fixed point does not affect the rotation. So when we rotated it on a x-axis on 90 degrees, theta is 90 degrees here. So when we rotated by fixing the x-axis, now here is the y and z coordinates can rotate, but x coordinate is fixed. So when we rotated it on x-axis on 90 degrees, then it will just appear like this. And again, if we rotate further on 90 degrees, but this time we are gonna fix the y-axis. About the y-axis, we just rotate the 90 degrees on 90 degrees, and now the z and x-axis are movable, and this y-axis is fixed point. Now after this rotation, it will appear like yes. It will just appear like this. So in this system, let's suppose this is the fixed point will remain same, and this is the z-axis, and here is the y-axis, and this will remain the z-axis, x-axis, sorry, x-axis. So now what we did here, we just rotated it on the angle of 90 degrees about the x-axis by fixing the x-axis. Now you can see in these three demonstrations that the fixed point is still same. So this is the Euler's theorem, that when a body is rotated in three-dimensional space, especially in space, then the it will always rotate around a fixed point. And when okay, let's suppose we just now gonna fix z-axis and rotate it on 90 degrees again, as we just did for it, the same process for x-axis and then y-axis, now for z-axis. Then what happened, then it will just come back to its original state, its initial state. So it will become a cycle, like it is a cyclic process. So basically the major basic point of this is that in any direction, in any rotation, this block is just rotating around a fixed point. So it is this fixed point is independent of the rotation. Doesn't matter what in which coordinate or in what direction or in what angle you are just rotating that body. The body will always rotate around a fixed point. That is Euler's theorem. And for Euler's angles, just wait for my next video, and in next video I will just explain you the Euler's angles. Thank you so much.